Everyone, today we'll study the concept of mutability and immutability in Python. So let's get started. First, let's take a look at the content that we are going to cover in today's video. The first is data types in Python. Next, we'll look at the object concept. Then we'll come to mutability and immutability of the different data types that we discuss. Then there's an important concept of aliasing and functional arguments and how they differ with mutable and immutable data types. And finally, we'll look at some of the applications, real life applications of mutability and immutability. So let's get started. So what are data types? Data types refer to the type of data that you assign to a variable. When you're writing a program, you work with variables. In mathematics, you work with variables. You usually work with the variable x, right? So you assign a value to it. In maths, you usually assign a number to it, but it can have different type, right? So let's discuss that. Python majorly supports two broad categories of data types, that are primitive data types and derived data types. So what are primitive data types? Primitive, as the name suggests, these are the building blocks of Python language, right? These are the very basic types that you can assign to a variable. So what are primitive data types? Let's look at them. The first one is integer, as you all know, right? Let's say I have a variable x and I assign a number to it, 5, 6, -1, 100, 200. And if I then print the type of it, so you can print the type of the data that you have assigned to a variable using the type function. Okay, so let's print the type of x. So the type of x is integer. It belongs to the integer case, right? Next we have float, right? Let's say we have x is equal to 5.6. Now, if we print type of x, we have class float, and the class integer is for the above variable x. So let's comment this out. Now let's comment this as well. Float, okay, I misspelled. So the next primitive data type we have is string. Let's say I have a variable x and I assign it a value of dog. And if I now print the type of x after saving it, so it belongs to class string. You can have a single character or multiple characters, right? The last derived data type, the last primitive data type we have is Boolean, right? Let's say I have x as true. And if I print type of x, and if I now print type of x, so class will be the same type. So we have looked at primitive data types. Now let's move to derived data types. What are derived data types? As the name suggests, these are derived from primitive data types. That is, when you have a collection of different primitive data types, for example, a collection of 50 integers or a collection of 50 strings. So instead of assigning 50 different variables, you can define just one variable of a derived data type, and you can store all those 50 integers or 50 strings in that derived data type. So in derived data types, firstly, we have list. Let's say I have a variable L and I have a collection of integers 1, 2, 3. So this list L represents a collection 1, 2, 3 of primitive data type integer. Okay. So next we have is tuples. Tuples also represent a collection of primitive data types, for example, integer strings or a mixture of strings and integers. But there are some differences between lists and tuples. So that is a homework for you. You can check them out. So tuples. So how do you define a tuple? You define it with open brackets, let's say 1, 2, 3, right? Let's define it with the variable t. Now, if we print type of L and if we print type of t, let's see what gets printed. So L is a list and t is a tuple. Now there is one more derived data type that we're going to cover in this class, that is sets. So sets are basically mathematical sets that you have studied. So let's say I have a set S, I define it with curly braces. It is also a collection of primitive data types, but there are some differences between sets, lists, and tuples, which you can check online. For example, sets, they are unordered. You can't refer a variable, you can't refer an element of set by using indexing, right? So if I print the type of S now, You can see class set. Now let's move to the object concept in Python. That is a very major concept that you must know. So what is the object concept? So everything, every variable in Python is an object. Okay. And there are three major properties that are associated with those objects. The first one is the type, which we just discussed, right? If there's a variable, there's a type associated with it. If it's an integer, if it's a string. The next major property, the next major characteristic is the value of the data itself. For example, if it's an integer, x is equal to 5, then 5 is the value of the data, right? And the last one is ID. So this is very important, the ID characteristics. Okay, so we are discussing object model in Python. So what does ID represent? A program gets loaded into memory, right? Into RAM. So there is a memory location where this variable's value gets stored. So this memory location is referenced by this variable ID. So this ID stores a number that represents the memory location in the RAM. It doesn't actually represent the exact memory location. There must be some mapping. So it just gives the memory location, a mapping of the memory location in RAM where the exact value of this object is stored. Okay, let's see an example. Let's say I have a variable x. X has a type of integer and it has a value 5. Okay. Now if I print id of 5, print id of x, let's see what gets printed. So there is this huge number that is mapped to a memory location in RAM. Now let's say, so this huge number represents the memory location, a mapping of the memory location in RAM where this value 5 of the variable x is stored. So x just references or points to this memory location in RAM where this value 5 is stored. All right, so the object concept is clear. Okay, now let's move on to the concept of mutability and immutability. We'll use this ID function a lot there. Okay, so let's get started. So let's get started with the mutability and immutability concept. Mutability, as the name suggests, it is derived from the English word mutate. Mutate means to change. So mutability means that you have a variable, let's say x, it has a value that is stored at a memory location in the RAM. If you are able to change the value that is stored at the very same memory location, then the variable or the data type is said to be mutable. For example, you have a variable x that has value 5. Okay, we have a variable x that has value 5. It is stored at a memory location, let's say this memory location 140726. Now, if you want to change the value that is stored at this very same memory location 140726 to, let's say, 7 instead of 5, and if that is possible, then x or the data type integer is said to be mutable. Now let's see mutability and immutability with respect to different data types. For example, let's start with integers. Okay, integers, let's say I have a variable x is equal to 5. Now let's print out the id of x. Okay, now let's say this id will get printed. Let's see. Yeah, now let's say I write x is equal to 7. So what do you think, what might happen? Okay, so your first guess may be that at this very memory location, that is 1407 blah blah blah, at this very memory location, instead of 5, 7 will get stored in RAM, right? Now let's print the id of x again. As you can see, the id of x, initially it's this 1407 and it ends in 248, but the id of x got changed. It now points to a different memory location. So x initially pointed to this memory location, that is where the value 5 was stored. Now when we change the value of x to 7, x now points to this memory location that has the value 7. Now you might ask, what would happen to this original memory location where 5 is stored? So that is taken care by garbage collection procedure. So that is a completely different process, which we'll discuss in some other video. So this memory will be freed up and will be assigned to another variable if required. But the main point to notice is X now points to a different memory location, which now stores the value 7. We can say that the integer data type is immutable. That is where the original value is stored, the memory location. You can't store another value at the very same memory location. You can't change the value there. Okay. So hence integers are immutable. Now let's look at float. Okay, let's say X is equal to 5.6 and we print the ID of X. Okay, now let's change the value to, let's say, 4.5. Okay, what we are doing is we have assigned 5.6 to a variable X. So there must be a memory location where this 5.6 value will be stored when it is loaded into RAM. Now what we want to do, it should be 4.5. What we want to do, we want to store 4.5 instead of 5.6 at the very same memory location. Let's see if that happens. So as you can see, both the IDs are different. That is, X now points to a different memory location. The original memory location is now taken care by garbage collection. It can be freed. It will be freed after some time since it is not pointed by any variable at that time. Okay. Now let's say a Boolean data type that takes two values, true or false. So that is a homework for you to check if Boolean data type is mutable or not. Okay. Now let's look at strings. Okay. So let's say I have a string s is equal to dog. Okay. What I want to do is I want to change the first letter of dog to H so as to make it hog. Okay. So what I want to do is S, the string dog must be stored at a memory location, right? It must be stored at a memory location. Now what I want to do is at the very same memory location, instead of dog, I want the string hog. Let's see if I'm able to do it. Let's say I do S of 0 is equal to H. I am changing the first letter of S, the first to H. Okay, I'm changing the first letter of dog to H. Okay, let's see if that happens. See, I've got an error. String object does not support item assignment. This means that strings are immutable in Python. String values are immutable. Now you can say that what if I assign S to hog, right? Let's see what happens. Let's print the ID of S here. And here also let's print the ID of S. Let's see what it's printed. So as you can see, both the IDs are different. When S points to this memory location, it is pointing to dog, right? But when we assign a different value to this variable S, that is hog, S points to a different memory location. So at the same memory location, we haven't changed dog to hog. Python is not letting us do it. Why? Because strings are immutable in Python. Okay. Now let's see tuples. Okay. We discussed tuples earlier. So let's say I have a tuple t 1, 2, and I want to change the first element of this tuple to, let's say, 3. So t of 0 as 3. Okay, let's see what happens. If I run this code, I have again gotten an error. Tuple object doesn't support item assignment. Why? Because tuples are also immutable. So this is the major difference between tuples and lists, that tuples are immutable, and we'll see next that lists are mutable. Right? Okay, let's see lists now. By the way, you can do the same thing with tuples as well. You can assign 3, 2 to t and then check the IDs. The IDs will be different. So that is a homework for you. Okay. Now let's see lists. Let's say I have a list L as 1, 2, 3. What I want to do is I want to change the first element of this list, that is 1, to let's say 8. Let's see if I'm able to do it. Let me clear the console first. Okay, let's see if I'm able to do it. I'm able to do it. I haven't gotten any error. Now let's say I print the ID of L here and let's say I print the ID of L again after changing the value to it. Let's see if these both are same or not. As you can see, these values are exactly the same. What we have done is this list L has a value 1, 2, 3 that is stored at a memory location given by this 25219, etc., etc., etc. What we did, we changed the first value of this list, that is 1 to 8. And then if we print the ID again, it is the same. It means that at the very same ID, at the very same memory location in RAM, we have changed the list value from 1 to 3 to 8 to 3. This implies that lists are mutable. Now let's look at dictionaries. Dictionaries are another data type, right? So let's say I have a dictionary. It stores key value pairs. Let's say the number of oranges I have. Let's say I have 50 oranges, or the number of apples I have. Let's say 100 apples. Okay. What if I want to change the number of oranges to 100? I can do like B of oranges to 100, and let's say I want to add another fruit, bananas. D of bananas is equal to 90, let's say. Let's see if we are able to do it. If I run this code, I get no error. This implies that dictionaries are also mutable. You can print the ID of dictionary here. Let's print it. Print ID of D and print ID of D again here. So as you can see, both the IDs are exactly the same. This implies that dictionaries are mutable. Okay, so there is one more derived data type left known as sets. So that is left as a homework for you to check if it is mutable. Now let's move to the concept of aliasing and functional arguments. So what I mean by aliasing, let's say I have a variable X, it has a value 5. Okay, I have another variable Y, then which points to X. Okay, which points to X. What if I print ID of X, and what if I print ID of Y? Will these be same or not? Let's see. So these two IDs are exactly the same. X is pointing to this memory location that stores the value 5. Y is equal to X. This implies that Y also points to this memory location that has the value 5. What if I change the value of Y to 7? What will happen? Let's see. Let's print ID of X again here and ID of Y again. Okay. So the ID of X, ID of Y initially are same. ID of X remained same, but the ID of Y changed. Why? You know the answer, because integers are immutable. So when you changed Y to 7, Y now points to a different memory location that has the value 7. But X keeps pointing to the original memory location that has the value 5. Okay. So this is known as aliasing. But what if we have mutable data types? Let's say I have a list L that is 1, 2, 3. Now I make another list, let's say B, and it points to L only. Okay. Now if I do B of 0 is equal to, let's say 4, I change the first element of the list to 4. Okay. Now if I print ID of L, and if I print ID of B, let's see if they get changed or not. Let's say I print ID of L here as well. Okay, let's see. Now let's say, as you can see, all these IDs are same. Why? Because L is a list. It initially has an ID of this, the memory location where the value of the list is stored. B also has this value. Why? Because it is pointing to L only. Now, when we change the value of the list that is pointed by B to have 4 instead of 1 as its first element, then what happens is that the memory location where that list is stored, that memory location stays the same and the value gets modified, right? Because lists are mutable. So at the very same memory location, 1 gets replaced by 4, and the ID of L and the ID of B both remain the same. Why? Because L is pointing to that ID. B, when making this change, won't point to another memory location. Why? Because lists are mutable. So both L and B point to the very same memory location, even after making changes. So this is the concept of aliasing. Now let's look at functional arguments. Okay, let's say I have a function subtract 5, and it takes list numbers as a parameter. What does it do? It subtracts 5 from each value in that list. Okay, so for I in range 0 comma length of numbers, we iterate through the list. What we do is numbers of I is equal to numbers of I minus 5. Okay. And what we do is we return numbers, right? So let's say I have a list L is equal to 1, 2, 3. Okay, I print its ID, print ID of L. I get another list, B is equal to subtract 5 of L. And if I now print ID of B, what do you think will happen? Let's see. If I run this code, both these IDs are exactly the same. Why? Because lists are muted. So what is happening here? We initially have this list L as 1, 2, 3. We print its ID, it is 2497, blah, blah, right? Now we call this function subtract 5 and pass this list L. Now what will happen is aliasing will take place, right? This numbers parameter will now point to the memory location that has the value 1, 2, 3 that is pointed by L. It will point to the very same memory location. Now we are mutating the list, right? We are changing the value of the elements to element value minus 5, right? We are doing that in place at the very same memory location. We are changing the values because it is allowed in lists. Why? Because lists are mutable. Now, if we print the value of the return variable of this function, if we print the ID of it, we can see that it is exactly the same. Why? Because we have changed the value from numbers to numbers minus 5 for each element of numbers. Now, what if I print L? What if I print L, right? Now L will have -4, -3, -2. So that is a drawback, that we have lost the original values in the list, right? So what we do as a workaround, we say we have another list, new list, let's say empty list result. Now what we do is we do result dot append numbers minus 5. And then we do return result. So what if we run this code? The original list L remains as it is. Why? Because we have created a new list result. So that is the concept of functional arguments. Now, what are the applications of mutability and immutability, right? So in case of mutability, let's say you have a shopping cart, right? You want to add and delete items. You're going to Amazon, you want to add and delete items, right? So instead of making new lists again and again, you have a mutable data type of list. You keep adding items into that and you keep deleting items from the same list. Instead of making copies of lists and storing that into RAM, it will consume a lot of memory, right? Now let's say you have your Aadhaar card number or your date of birth. You store those as strings. Why? Because strings are immutable and you don't want your Aadhaar card number or your date of birth to change, right? By anyone. So these are some real life examples of mutable and immutable.